In this problem, we're going to find V0 using mesh analysis, problem-solving strategies, AC steady-state analysis, and loop analysis. And our first step in our strategy for loop analysis says identify the loops and assign currents. So we have three meshes here. We're particularly doing mesh analysis. So I'm going to define the currents I1, I2, and I3. So we have three unknowns, I1, I2, and I3. So we're going to need three equations. And we're going to get those equations by applying KVL to the three meshes. We don't have any current sources, so we don't have any constraint equations. So let's start with the upper left mesh, applying KVL. Okay, so we'll have 4I1 plus J4 times I1 minus I3 plus J2 times I1 minus I2 is equal to 24 to angle of 0. And this simplifies to 4 plus J6 I1 minus J2 I2 minus J4 I3 equal to 24. Okay. So here's one of our equations. And if you look, really, when we get through writing our equations, we only need to solve for I3 because I3 is the only mesh current that flows through this element for which the voltage V0 is labeled across. Now let's write our other two equations. Okay, so now we're going to need two more. We've already written KVL for that one. We need to write KVL for this mesh and for the mesh on the right. Okay, so for this mesh, we've got J2 times I2 minus I1 plus 6 times I2 minus I3 plus 2 VA plus 4 I2 equal to 0. So now let's simplify this one a little bit. We'll have minus J2 I1 plus 10 plus J2 I2 minus 6 I3 plus 2 V8. Now we've got our variables I1, I2, I3, and also VA in this equation. And if we look at our problem solving strategy, it says that in step 3 we're going to need to express the controlling variable for those dependent sources in terms of the loop currents. So if we look at VA over here, let's look at where it is in the diagram. Okay, so VA is given here, and if we look, then VA is minus 4 times I2. So if we substitute that in, we'll have 10 plus J2 I2 minus 6 I3 plus 2 times minus 4 I2. Then what we get is we get minus J2 I1 plus 2 plus J2 I2 minus 6 I3 equal to 0. There's our second equation. Now we've still got one mesh left, and that's the one on the right. So Let's write the equation for the one on the right. Okay, we'll have term right, we'll have 3 minus J2 I3 minus 2VA plus 6 times I3 minus I2 plus J4 times I3 minus I1 equal to 0. So now, if we go to simplify, we'll have minus J4 I1 minus 6 I2 plus 9 plus J2 I3 minus 2VA equal to 0. If we make our substitution, we'll have minus J4 I1 minus 6 I2 plus 9 plus J2 I3 minus 2 times a minus 4 I2. And this simplifies to minus J4 I1 plus 2 I2 plus 9 plus J2 I3 equal to 0. There's our third equation. And as we've already discussed, we really only need to solve for I3 because that's the only mesh current that flows through this element. So, solving for I3 using MATLAB yields I3 equal 0.7327 at an angle of 77.66 degrees. And then V0 is minus J2 I3, which is 1.4654 at an angle of minus 12.34 degrees.